carboxylic acids will form esters. How is it that they form esters? They do this through a condensation reaction. Remember how we took ether and an alcohol and an alcohol, and we condensed it, meaning removing water, together to form an ether? Well, we're doing almost the same thing here, but it's a different functional group on one of them. On the right of the products, reagents, we have an alcohol, ROH. On the left of the products, we have a carboxylic acid, C double bond O, OH. To condense these together, we remove water. So we can remove water by taking the hydrogen from the alkyl group and the hydroxyl group from the acid. The two remaining parts are then joined together to form an ester. This is an equilibrium reaction. It was the same thing with an ether, but I didn't talk to you about that. But here, this is an equilibrium reaction. I can take an acid and an alcohol, like I'm showing you down below, and it forms an ester. But the ester can be broken apart with water to make an alcohol and a carboxylic acid. So this is an equilibrium that we see here. Acid and alcohol on one side and ester and water on the other side. However we want this equilibrium to go, we can do by adjusting concentration. If I remove lots of water, that's going to cause the concentration of the ester to increase. And so removing water is one way of making the ester form. If you have the ester and you're wanting to get the alcohol or the acid, what do? We add lots of water, and what happens is we force a reaction to the alcohol and acid side. Sulfuric acid is a catalyst in this reaction. The esters are like the acids in that they have a higher melting point and boiling point than that of the alkanes with a similar molar mass, but they cannot hydrogen bond. They have dipoles, so they're polar, and they have dipole-dipole intermolecular attractive forces, but they cannot hydrogen bond, so their melting point and boiling point are much lower than that of the alcohols and the acids with similar molar masses. If you get an ester that has more than 5 carbons, you find that it is water insoluble. In fact, the ester with 5 carbons that we have, ethyl acetate, it really is relatively water insoluble. Only a small amount of it will dissolve in water. Esters are the sweet smelling compounds, and many of the flavors and fragrances that we associate with pleasant smells and pleasant tastes are esters. Esters are named by first identifying the acid and the alcohol portion of the molecules. Once we find the alcohol portion of the molecule, you name that alcohol portion, then we take off the "all" off the name and make it "ill." So basically we're identifying it as an alkyl group on the ester functional group. Then we identify the acid portion of the molecule, you name that acid, and then you take off the oic acid from the acid name and you add 8 after it. Here's an example of how we can see a reaction of an acid and an ester forming, and then we can name it too. If you look at this, you can see there is acetic acid plus ethanol gives us an ester. The acid portion is the acetate portion, CH3C, and then the oxygen's attached to it. The alcohol portion is the CH3CH2 on the left-hand side of that molecule. We name the alcohol portion ethyl because it comes from ethanol. We take the anol off and put "il" on the end. And then we name the acid part. It was acetic acid, so we take off the ic acid and we put on "ate." So it becomes ethyl acetate. So go ahead and try this problem. What ester comes from propanoic acid and butanol? And I'd like you to do it the same way that we did above. Draw a structure for propanoic acid, draw a structure for butanol, draw an arrow, and then draw the products of the reaction, and then name the ester. Propanoic with its 3 carbons is written here, and you can see one of the carbons is in the carboxylic acid group, and then there's 2 carbons written beside it, so that's propanoic acid. Butanol has 4 carbons, which we can see here. Now, when they form an ester, remember you're going to take one of the OHs off of one compound and just a hydrogen off the other. And when we do that, you can see 1, 2, 3 on the acid side. The acid portion of the molecule has a carbonyl in it. And then 4 on the alcohol side. The alcohol side of the molecule does not have the carbonyl in it. This is called butyl propionate. Why butyl propionate? Because there are 3 carbons on the acid side. We take the propanoic acid and take off the oic acid and put on O8. And then we take the butanol name for the alcohol portion. We take the anol off and put "il" on it, giving us butyl propionate. Esters can be broken apart or hydrolyzed into the acid and the alcohol in the same way that they were joined together. Now, if we look at this, we can see that this ester on the left has on the alcohol portion, notice there's no carbonyl on the alcohol portion, so the alcohol portion is from methanol. And if I look at the acid portion, you can see there's only 1 carbon on the acid portion. So we call this molecule methyl methanoate. It can be broken apart into methanoic acid and methanol. You can see that the carbonyl, the portion of the molecule that has a carbonyl is the 1 carbon with the 2 oxygens attached, so it makes an acid. Hydrogen, carbon, 2 oxygens attached, and then a proton. If I look at the alcohol portion, you can see it's a methyl that is attached to an oxygen, so afterwards we have a methyl that is in an alcohol formula, so it's CH3OH. Now below you can see we have 2 problems to do. What acid and alcohol are formed from the hydrolysis of this compound here, and what acid and alcohol are formed when butyl ethanoate is hydrolyzed. One place I'm giving you a structure, another place I'm giving you a name. When I give you a name, in order for you to figure things out, you need to draw the structure of that molecule. The first thing to do in this problem is to draw out the ester and water. We're doing a hydrolysis, and the word hydrolysis actually means water cutting. So water is actually going to be used to cut this molecule in half. How we cut it is going to be what we go through now. So you can see that I've drawn out the structure so you can see the carbon-oxygen double bond, the carbonyl. If you look at the way that the ester is written in the problem, you can see there are 2 oxygens following the 3rd carbon. Those 2 oxygens are both bound to that carbon. That means that one of them has a carbon-oxygen is in a carbon-oxygen double bond, and the other one is in a single bond, as I've drawn. So when you redraw it this way, it is much easier to identify how to break the molecule apart. If you look at the problem, it says what acid and what alcohol are formed. We can figure that out by looking to see how the molecule is put together. Which is the acid side? Well, the acid has to have a carbonyl functional group in it, doesn't it? So we should choose the side that has the carbonyl in it to become the acid. The alcohol portion has only a single bond to the oxygen, so we have to choose the side of the molecule that has a single bond to an oxygen as the alcohol. So let's go to the next, and we'll see that I've rewritten the acid to have the 3 carbons so that you have the same structure to the acid as the carbonyl side of the molecule, and then I've drawn the alcohol to have the same carbons that are on the alcohol side of the molecule. Notice the water became the proton on the acid group and the hydroxyl group on the alcohol. To do this problem, again, the first thing you have to do is take the name, butyl ethanoate, and draw it down there as an ester. It says hydrolyze, so you know you have to have water in there to cut the molecule, because hydrolyze is the verb form of hydrolysis. So we're going to cut this molecule with water. What acid and what alcohol form? We look at the molecule and say which side has the carbonyl on it. You actually could have written this molecule so you had 4 carbons on the left, a single bond to oxygen, the carbonyl, and then the CH3. You can write it both ways and it's the same molecule. So you have to look for the side of the molecule that has a carbonyl in it. That's the acid side of the molecule, and that will become our acid. You can see there's 2 carbons, so it's going to become ethanoic acid or acetic acid. The alcohol side is the part that has a single bond to an oxygen, so that is going to be 4 carbons to an oxygen. I can draw. There's the acetic acid with 2 carbons, and then there's the butanol with 4 carbons. Notice the name butyl ethanoate, the part that has the ill comes from the alcohol, so it goes from butyl to butanol. The part that has the O-weight on it came from the acid, so it goes from ethanoate to ethanoic acid.